Hello everyone, welcome to Coders Camp. So today we are at the fifth video of our recursion series. In our previous video we have seen what is memoization and how to work with recursion and memoization, and we have seen an example of a Fibonacci series, how we work with memoization and recursion to work on that problem. So today we are going to see another problem that we are going to solve using recursion technique and memoization. Let's get into the problem statement. Here we are going to cover maximum score from performing multiplication operation. This problem has been asked in a weekly contest of lead code. So the input given here is a two integer array nums and multipliers. We have to return the maximum score after performing operations. So the operations we can perform here is choose one integer x from either the start or the end of the given array, add multipliers to into x to the score, remove x from the array. So let's understand this problem first with an example. Consider our first element in our multipliers array, that is -10. So we are checking whether multiplying it with the first number or the last number gives us more value. So starting with multiplying -10 with -5, gonna give us 50. So as we have used -5, let's take it off and moving on to a second value -5. So let's check multiplying it with -3 or 1 is going to give us higher value. So let's consider 1. So -5 into 1 is going to give us, no, -5 into -3. So -5 into -3 is going to give us 15. So moving on to a third value 3. So now it's time to multiply it with -3 or 1. So multiplying 3 with 1 is actually going to give us more value. So 3 into 1 is going to be 3, but this is the wrong step we are taking. I'll tell you why later, but let's consider we have multiplied it with 1 and moving on to our next element 4. 4 with 7 or -3. 4 with 7 is going to give us the higher value, so we are going to multiply it with 7. So 7 is going to be 28. And finally moving on to a 6, multiplying 6 with -2 is going to give us higher value. So 6 into -2 is going to give us -12. So this actually sums up to 84. But if you consider the first and second value as such, so instead of this step, that is multiplying 3 with 1, let's consider we multiply 3 with -3. So in this case, if we multiply 3 with -3, we're gonna get -9. So as we have used -3, the rest of the values left in nums array is gonna be -2, 7 and 1. So now moving on to our value 4, let's consider we multiply 4 with 1. It is going to give us 4, and finally our 6. So we have used 1. So now we check whether 6 has to be multiplied with -2 or -7. So 6 with 7 is going to give us higher value. So 6 into 7 is going to give us 42. So adding these values plus 15 and 50 is going to give us 102. So now by just changing one value, we have achieved at our better solution 102. So checking 1 and the last value, whichever is giving higher value every time, doesn't give us the optimal or the best solution we needed. Instead, we have to check every possibilities. That is, if we take this value, we have to check both the values and further steps, and if it is giving lesser value, we have to backtrack to the step and then try different values to come up with a better solution. So in order to do that, if we get problems like this, that is trying out all possible values, greedy solutions, or recursion are going to help us achieve the solution. So here the recurrence relation we found is, if we are considering this first number from multiplier or each number from multiplier and considering the first value, then our rest of the values with rest of the values at nums is going to be added to that value. For example, if we are considering -10 and -5 from arrays, this is our particular value along with that, rest of the values in nums, that is from -3 to 1, into rest of the values at multipliers, that is -5 to 6, is going to perform the operation and add it with the result. If not, we are going to consider -10 and 1. Similar way, the rest of the array from -5 to 7 and -5 to 6 from multipliers is going to perform all the operation and add with this result. So let's see how we're going to code it recursively before applying memoization. So as usual, we are going to have a helper method which is going to return the largest value. So let's have our nums array A and multiplier array M, and the starting and ending index of nums array, because if we consider the starting index, it is going to be from the second element till end. If not, it is going to be from the first element to end -1. So to indicate the index of where we are considering the array, we are going to have int start and int end, and one more integer which is going to point at the multiplier index. So m index. So let's start. So we are going to start by having values 1 and 2. That is, if we are considering the first element from the array, that is going to give us one value. If we are going to consider the end element from the array, that is going to give us the one more value. So we have to return the maximum of both the values. In that case, I'm going to have value 1, which is going to take the current index from multiplier array and multiply it with first the starting index of the nums array, and one more integer value which is going to take the same number and multiply it with the ending index value, and finally we are going to return max of value 1 comma value 2. So now here, as we have multiplied the first number with the starting value, the rest of the operations will be from, we are going to call the same helper method and pass array nums and multiplier and the starting index set as start plus 1, and the ending index is going to be same, and every time we considered one value, our multiplier index is going to move to the next number. So m index plus 1. So as we have considered the first element, we are going to send the rest of the array as a parameter to process. The same way with value 2, I'm going to call the same method with starting at the same point, but end is going to decrement by 1, because if we consider the end element, we are going to remove it and consider the index moved one step forward, and m index going to add. So now we found the recurrence relation and constructed our code. So we have to stop this code by using our base condition. So here the base condition is, we are going to do the operation or perform the operation m times. So m is nothing but the size of the multipliers array. So here the m index is going to point at every element in the multiplier array. If it points at the last element, which means we are done performing all the operations and we have to terminate the loop or terminate calling the recursive function. So we are checking if my m index is equal to the multipliers dot length, that is every time we are iterating it, and if it reaches its length, which means we processed every element in the given array, so we are going to return simply 0. So this will terminate calling the methods again and again and simply return 0. So now from our main method, let's call the helper method. We are going to pass the nums array, multipliers array, and the starting index as 0 ending index says nums.length minus 1, and the multiplier index also starts from 0. So once it reaches the complete length, we iterated all the values and it returns 0 as our output. So let's run this code. Yes, it is running fine and giving us the actual output we needed. But if you submit this code, it is going to give us time limit exceeded. Yes, time limit exceeded for the input. So how do we execute it without time limit exceeding? To see that, let's understand how the recursive functions are called. So our helper method is having the parameters, that is starting index of the nums, ending index of the nums, and the multipliers index. So let's consider we are starting from the index 0 and considering the first element and the last element 5. So this further calls the first element and considering the first index. If we are considering the first index, that is minus 5, the rest of the array is going to be from 1 to 5. So starting index is going to be 1, end index going to be 5, and multiplier index is going to be 0. Same way, if we consider the last element 1, it is the rest of the array is going to be 0 to 4. So 0, 4, and then 0. Further, this element is going to call, if it is considering the first element, the index starts from 2 to 5, and then for the first element of the multiplier array. If it is considering the last element, the index starts from 1 to 4 and then considering the first element. Same way, if it is considering the first element, it is going to be 1 to 4 and then for the first element of the multiplier element. Same way, if it is considering the last element, the index is going to be 0 to 3 to the first element of the multiplier element. Further, if you call, these elements are going to be giving us so this tree goes till the last multiplier index becomes 4. That is, it starts from the 0th index and one level for index 1 and second level for 2 and one more index for 3 and level 4 for 4th index, and it terminates when it reaches the size 4. So now if you observe the values here, 141, 141 are equal, and 132, 132 are equal, and you can find so many values are repeating. So this is duplicate of operations. As we saw in a previous video, we are performing extra operations or repeated operations in our solution. So to avoid that, we are going to implement memoization. That is, if we see these steps are already defined or performed in our code, we are going to store its value and then retrieve it when we needed it again. So let's see how we're going to alter our code. So in our previous video, we implemented Fibonacci series memoization using a hash map. Here also you can use hash map to store the values and retrieve it later. Just for a change, I'm going to implement it using arrays. So I'm going to have an array dp which is of size 1000 cross 1000, because here in our description the limit given here is yum can go 10 of size 10 cube. So we have declared here the array of size 10 cube. So now we are going to store the values here. That is, our dp of m index start is going to be we're going to store the value in our array and then return the value. So every time it enters the loop, we are going to check. First, we are going to fill the array with -1. We are going to fill the value with -1. So we are going to check if it's not equal to -1, which means we have updated the value, then return the value which is stored already. So let's run this code. Okay, let's not try filling the values. The default value in array is going to be 0. So we are going to check if the value is not 0, then that is the case. We have already filled our array. So we are going to return the value. So yes, let's submit it now. So yes, now our solution is accepted. Our previous solution using recursion was not accepted, but after implementing memoization, it is accepted. So hope you're getting how to use memoization when needed. That is when we perform duplicate operations, memoization comes to help where we store our values and then return it whenever we need it, whenever we need to perform it again. Thanks for watching. Look for more videos on recursion. If you like the video, hit like and subscribe. Thank you.